Hey, geometry students, just a quick summary of the last lesson in topic 3, rigid and non-rigid transformations. So you saw at the end of the translations lesson and then the beginning of this when they talk about these translation vectors. So just want to make sure we understand what a vector is. First of all, this is the notation right here. So it kind of looks like an ordered pair, although you don't have parentheses. You have these symbols instead. And what it does is the vector is actually kind of telling you movement. It's telling you direction and how far to go. So this 2 right here tells you 2 units in the horizontal or x direction, and it's positive, so that would mean to the right. The -1 is in the like where the y coordinate would be. So that tells you vertical movement, and since it's -1, that means it would be down 1. So this vector describes movement 2 to the right and then down 1. And then some other things in this lesson were introduction to proofs, which we'll get to later in geometry. But basically, it just wanted to make you aware that you can use coordinate geometry and these transformations to help you with proofs. So in this one, it went through this proof, and the bottom line was you were trying to prove that the distance from AB was the same as the distance from CB. Okay, so they went through all of this, and I hope that all of this right here you could follow and actually draw this picture on your own, just giving these steps. Okay, that would be a really good test for yourself right now. So draw all of this stuff, and then this was kind of a continuation where they actually performed a reflection from point C across the y-axis, and it mapped right onto point A. So that told us that this distance was the same on both sides. And then therefore, when we mapped it, the triangles actually mapped up as well. So it told us that this distance mapped to this distance, and then therefore they're congruent, and that's that they're the same distance. Then you saw kind of another example of how we can use coordinate geometry. They talked about this transversal. So transversal is a line that intersects 2 or more lines. In this case, it's intersecting parallel lines, at least what we believe to be parallel. And you were supposed to use algebra to show this. So when they say use algebra, we know that we learned in algebra this formula for slope. And we know that parallel means the 2 lines have the same slope. So I'm just going to walk through finding the slope of each of these and just to prove that it's the same. So let's do line AB first. So following slope formula, so this point and this point, we would have, let's say, B minus 0 over 0 minus A. Y2 minus Y1, x2 minus x1. So b minus 0 is just b. 0 minus a is just going to give us negative a. So the slope of AB is right here. We could also write it as just negative b over a. Either notation is fine. So now let's look at a prime, b prime. So again, following our slope formula, we would have b plus d, this quantity, minus the y-coordinate of this, which is d, over 0 minus a. So just simplifying up here in the numerator, the parentheses were just to group this together. They're not really doing anything else. So we have positive d, we have negative d, or minus d. Those are just going to end up canceling each other out. So that leaves me b. 0 minus a is negative a again, and look at that. Our slope is the same no matter how I write it or no matter where I put the negative sign. No matter which notation, those lines have the same slope, which proves they are parallel. It also went on, once we know that they're parallel, and this is a property we'll learn later on, that corresponding angles are congruent when they are formed by a transversal intersecting parallel line. So you have these parallel lines, you have this transversal intersecting them. They're just saying that corresponding angles are congruent. It was this angle and this angle that they were talking about were congruent, but the other ones would be congruent also when you have parallel lines and a transversal going through them. So again, they just use coordinate geometry to do that. We're just looking at kind of some applications here. Quick review of all of our different transformations. These are called the rigid transformations. You have reflections, rotations, translations. Those are rigid transformations. They preserve the size and the shape of the original image, and it's congruent to the transformed one. Dilation is a non-rigid. You just learned dilation in this lesson. Dilation basically means it gets bigger but keeps the same shape. It's multiplied by some scale factor, and depending on the scale factor, so if this scale factor is bigger than 1, then it's going to enlarge it. If it's, so let's call the scale factor S. If it's between 0 and 1, then it's going to be a reduction. Okay, and this one preserves the shape but not the size. Vertical and horizontal stretches were actually things we talked a little bit about last year in Algebra 1. These do not preserve size and shape. Okay, imagine taking some image that you're going to put in a Google slide or something, and you want to make the image bigger, you want to make it smaller. In order to make it bigger or smaller and keep the same shape, you need to perform a dilation, which would be where you grab like the corner of it and make it bigger, or the corner of it and make it smaller. That would preserve the shape of it, not the size. A vertical or a horizontal stretch would be where you take this image and you just pull the side, or you just pull the top of it and it distorts it, right? So a vertical stretch, horizontal stretch, they don't preserve the size or the shape. They just stretch it one way or the other. So I liked this at the very end of the lesson just to wrap things up. So we know that reflection, rotation, translation, those are our rigid transformations. These are our non-rigid transformations. Rigid means it preserves size and shape. So for each of these, size and shape are preserved. Dilation, we know it preserves the shape, not the size, or at least not necessarily the size. Vertical stretch, horizontal stretch, those are the ones where we said it distorts it, doesn't preserve the size or the shape. So that's a wrap on rigid and non-rigid transformations. I hope this video helps you a little bit. Hope you guys have a great day.